All right, hey guys. In a prior video, I talked about simulating the measurement of effective focal length (EFL) of a lens during a Monte Carlo tolerancing analysis. All right, if you have not seen that video, just click on the link provided in this video to that video. All right, so back to that video. So what happened was I made a mistake, right? And it was a very stupid mistake. And now I'm going to own up to that mistake, all right? And basically, I was being an idiot and I was also being overconfident. What happened was I generated 1,000 Monte Carlo samples. I got the histogram and everything, but I did not open up a file, a Monte Carlo file, to check if everything was okay. And recently, when I opened up a file, I saw that the focusing was off. So, and that's very important. Okay, we'll get back to this in a minute or so. So when I went back to correct the focus, I now get a distribution at the bottom that's narrower than what I showed in the in the prior video. All right, it's narrower and very similar to the top distribution, but they are different. In fact, they are statistically significantly different enough to say that they're different. All right, because you get the standard deviation of the distribution, you get 0.305921 millimeters. And if you get this, you get 0.338059. They look very similar, but the fluctuation in each is very small. Okay, so here's the trick, right? How do you get this fluctuation? You can estimate it. You take this number here, the standard deviation, divided by square root of 2 times n minus 1 in brackets, where n is the number of Monte Carlo samples. So this is a very small fluctuation. This is a very small fluctuation, so they are different. So what this means is that tilts and decenters do impact the measurement system, and therefore they impact the measurement of the EFL. All right, and you can prove that farther by exaggerating the tilts and decenters. For example, here the tilts are 0.03 degrees, element tilt is 0.03 degrees, decenter is 0.2 millimeters. But if I exaggerate them to this amount here, you can see that the bottom distribution is um, bigger, broader than before, right? Okay, so I don't have much time left, so I'll just leave you guys with another thought, or actually a question and a thought. And the question is, why is it that focus was so important in this test? Why? Okay, there are several reasons. I can think of at least two. Okay, one of them is that the off-axis ray and the on-axis ray, they both translate a little bit when you're out of focus, right? And the second one is more fundamental. The second one is that the chief ray is not necessarily the ray that determines the height of the image, okay? And it's also not necessarily the centroid, because in reality, if you're using a small target object, at the image plane, there's a convolution of the point spread function with an edge, right? And the result is a sloping edge. And now you have to decide how you determine where's the edge? What defines the edge of your object, or what is the edge of the image of your object, right? And the definition alone will determine how you decide what is the image height. All right. So a lot of things have to happen, a lot of conversations have to happen, and a lot of thought has to happen as well. And I'll leave you with that. Thank you very much for your time. Bye bye.